Well, hey guys, and welcome back to Foundations of Physical Science for a little bit of remote learning today. We're switching gears. We're talking about our astronomy unit for a while here. And to get things started, I thought it'd be really neat to start thinking about gravity, this invisible force that kind of controls everything around us and in our lives, and something we've just, we're calibrated to and used to around us. But to think about what's actually going on, it gets pretty interesting. When we think about the way gravity behaves. So our goal today is for you to follow along, complete the notes, take a screenshot, and submit them to the assignment folder for classwork credit. We should get this done pretty quick, and then next class we'll be able to talk a little bit more in depth about gravity and think about how our weight is affected at various places around our solar system. It's kind of interesting to think about. So without further ado, let's jump in. Let's talk about gravity a little bit. This note sheet is posted to today's classwork folder, so make sure you go to Google Classroom and upload this note sheet to Notability, and working along in split screen so you can follow along, pause the video when you need to, and do not forget to screenshot and submit your notes when you're done for classwork credit. So let's talk about gravity here and what gravity actually is. We're going to describe gravity as a natural phenomenon, in which all things with mass are attracted to each other. And that mass is pretty key there. You have to have mass to have gravity. And we learned earlier on in the year that mass describes the amount of matter something is made up of. So essentially, if all matter is attracted to each other, right? If you have matter, if you're made of matter, if you have mass, then you have gravity. We each have our own gravitational pull, right? We're all, when we're in the classroom together, we're tugging on each other through gravity. We just, it's such a minute force at our mass that we don't feel it, and it's all kind of overwhelmed by the mass of planet Earth. But there's a couple different variables involved with gravity and the force of gravity. And, simply we said mass. And let's describe this relationship, though. Let's say as the mass of an object increases, its gravitational pull decreases. I'm sorry, Jason, that was wrong. I'm already ahead of the next one in my head. So as the mass of an object increases, its gravitational pull also increases, right? And that makes sense to us. The larger you are, the more mass you have, the more gravity, the more gravitational pull you're going to produce. And that's why we don't necessarily sense the gravity of those around us. We're all too small, but we're living on this big, giant rock hurtling through space, the Earth, that has a massive gravitational pull compared to everything else around it. And therefore, we're kind of overwhelmed by that. We're enslaved to the gravity of Earth, right? We're kept on the surface of Earth by its strong gravitational pull. So that's how mass is involved. The more mass, the more gravity. Now let's think about distance here, okay? So distance is going to be the opposite. As the distance between two objects increases, the gravity between them actually decreases. Let me give you a good example of this. Think about this. We are certainly pulled right to the surface of the Earth, right? We are kept kind of snug right onto Earth by its gravity. It's pulling us downward toward the center of the Earth all the time. But if we look at the Earth, maybe this big compared to the sun, which that's probably not even to scale. The sun is, giant compared to the Earth. It has way more gravity than the Earth. Why then, during the daytime, when our side of the earth is pointed towards the sun, don't we all get just sucked off the face of the earth towards the sun? You would think the sun, having much more gravity than the earth, would grab a hold of us and rip us towards the sun when it's daytime. And the answer there lies in the distance, right? We got this tiny little earth here. We got this giant sun way over here. And I don't know, we've got about 93 million miles between us. So, that distance, even though the sun is huge compared to the earth and has way more gravity, it's 93 million miles away. And its distance causes that gravitational pull on us as individuals to decrease to the point where we don't necessarily even feel it. It is there. We're just overwhelmed by that gravity of the earth because we're so much closer to the earth. So kind of an interesting phenomenon there to think about. Being really big, you're going to have more gravity, but the further you are from something, the less of an effect it'll have. So what we're going to do for today is we're going to skip this section here, this Newton's second law. We'll come back to that later on. We'll leave that blank for now. Really today, I'm just hoping you guys, we can get a brief introduction to this idea of gravity, especially these two variables here. The fact that as mass increases, gravity also increases, but as distance increases, gravity decreases. And then one last thing we definitely want to talk about here is this idea of weight versus mass, because this is a common misconception in science, what we're actually measuring when we measure somebody's weight or we measure the weight of something. Let's write this here. Weight is a measure of force due to gravity. Okay, now, and mass, we'll put right here, is a measure of how much matter is in an object. So when I measure the weight of something, when you weigh yourself, really what you're measuring is how hard is gravity pulling on me right now. And we know that the more massive you are, the more matter you're made of, the harder Earth is going to pull on you. And that's just, that goes back to this initial law of mass, right? So the more massive you are, the greater the gravitational pull on your body. And there you go. We've got weight, though, is a measure of force. How hard is gravity pulling on me? Whereas mass is just how much matter am I made of, or is this object made of? Now, here's where this gets interesting, okay? So if we think about this a little deeper, we would see that we could say your weight changes based upon how much gravity you are experiencing. All right, so your weight changes based upon how much gravity you're experiencing. So if gravity increases, you weigh more. If gravity decreases, you weigh less, right? We'll just say your mass does not. The classic example are those astronauts that went to the moon, right? Those guys, their mass didn't necessarily change, right? They were still made of the same amount of stuff, but they got to the moon and they weighed much less. They're in an environment with like a third the gravity of Earth. They weighed about a third of what they actually weighed on Earth. And, you could argue people at the International Space Station right now, they're living in essentially zero G, what we call microgravity. They weigh nothing. That's weird to think about, but they are weightless, right? They weigh almost nothing at the International Space Station, where, on Earth, their mass is no different up there, but their weight changes. Now, there's some crazy things that can happen to, fighter pilots that take really sharp turns in planes, and you'll get an increase in gravity. They'll talk about how many G's they're experiencing. Let's say you got a 150-pound, fighter pilot, and they take a turn in a jet and they experience 2 G's, right? They'll often use G there as our symbol for gravity. right? That fighter pilot during that turn, the mass in their body doesn't change, but they actually weigh 300 pounds. They don't look any different, but the force of gravity pulling on their body because of their acceleration they're experiencing, they actually weigh 300 pounds. And anybody who's been on that cool Gravitron ride at the fair, that thing that spins you around and kind of sucks you to the wall, you're experiencing that same exact phenomenon. You actually experience a dramatic increase in your body weight. You weigh more while you're on that ride because of that acceleration you're experiencing. It's kind of fun to you weigh so much that you can barely lift your arms up, and you're really struggling to move around, and that's an increase in gravity on you due to the acceleration that ride is producing. So all really cool stuff. Again, I'll zoom out here so you guys can see what you need to have written down. But really, all I'm looking for us to have today are, the definition of gravity, the fact that as mass increases, as does gravity, right? But as distance increases, gravity decreases. And that's, to review, that's the reason the sun doesn't pull us off the face of the earth during the daytime. And then finally, we're going to skip over Newton's second law for today, but down there at the bottom, weight versus mass, we want to know that weight is a measure of force. When we weigh something, we're measuring how hard gravity's pulling on it. But mass is just a measure of how much matter is in an object, and that doesn't necessarily change with weight. And so depending on where you are in the solar system, you may weigh more or less, and we're going to look at that next class. So that's why we got these notes done today. I will see you guys in class next time, and we'll continue this look at gravity. And don't forget to screenshot and submit the notes you took today to get yourself some classwork credit. Thanks a bunch, guys. We'll see you next time.